Alright, so we are looking at an example for a hypothesis test for a proportion, and we're going to look at page 356, number 10. I'm going to set this to the side. I'm going to pull out my textbook. I will read this to you. You may not be able to see it in the video, but you can read along with your textbook at home. So the question says, in the past years, at least 20% of students at State U chose to pursue public service careers after graduation. For an editorial piece on declining student commitment to public service, the school newspaper surveyed a simple random sample of 100 currently enrolled students and found that only 12 of them expressed an interest in a career in public service. So, past years, the assumption is 20% of students go into public service, but now we have evidence that maybe less than 20% go into public service. So let's keep reading. Does this sample result provide statistical evidence of a decline in student commitment for the population of students currently enrolled at State U? That is, can the sample result be used to reject a population proportion greater than or equal to 20 null hypothesis? Use a significance level of 5%. Show the null and alternative. Based on your sample results, should you reject the null? Alright, let's do it. So, I pull out a piece of paper here. I'll try to write big. Alright, so we've got a null hypothesis that says this population mean of all students at State U who want to go into public service is greater than or equal to 20%, 0.20. We're going to assume that's true, and we're going to gather some evidence to see if we find that that's not true. So our alternative hypothesis would be that the population proportion of students who want to go into public service is less than 20%. Alright, we had a sample proportion of 12%. All right, we asked 100 students, 12 of them said we're going into public service. So that's a good sample size. Assume we use proper sampling procedures. N equals 100. Okay, we at some point are going to need to find the standard deviation of the sampling distribution of sample proportions, but we'll hold off on that for just 1 second. Let's go ahead and draw a normal distribution and think about how we're going to visualize this. So this is sampling distribution of sample proportions. Sampling distribution sample proportions. We're going to assume, based on the null hypothesis, that the mean, the true population proportion equals 20%. And we're going to think about how we would assess information to the contrary. So the null hypothesis of the mean is greater than 20%. So if we went out and found a sample greater than 20%, we're like, all right, fine. You said greater than 20%. It's greater than 20% based on our sample. Where we're going to be concerned is if we find a sample proportion less than 20%, and in fact significantly less than 20%. And I guess I forgot to put the confidence or significance level here, so I'll put it now. Significance level, I believe, is 0.5%. Yes, 0.5. So we're looking for the 5% of the time, alright, that we would get a really low sample mean. And we're going to say, well, under your assumption, the sample, I keep saying sample mean, I'm sorry, but sample proportion. Under your assumption that the proportion is truly 20%, we're going to look for a result that would only happen 5% of the time. And if it happens, we fall into that 5% of the time, we're going to say that's so unlikely that we would rather say your assumption is incorrect than say that that happened by chance. So we'll call this our rejection region. Alright, so So let's find the critical value, the z value, associated with that rejection region. It's going to be the z value that separates the bottom 5% of the data from the top 95% of the data in any normal distribution. And we know that number to be 1.65. If you were to look on your z table, you would see, or excuse me, negative 1.65, you would see that the negative 1.65 has an area under the curve of 5%, meaning it separates the bottom 5% from the top 95%. So we're going to be looking for a test statistic for this sample proportion of less than negative 1.65. If it is less than that, we're going to reject the null and assume the alternative. Okay, well, let's go ahead then and calculate our standard deviation of our sampling distribution of sample proportions. Now, if you recall from, I think, a couple slides ago, the proportion we're going to use to calculate this is the assumed population proportion under the null hypothesis. It's the 20%. We're not going to use the 12% to calculate standard deviation. We're going to assume what they say is true, or assume the assumption is true, and we're going to see what would the standard deviation be under that assumption. And if it falls in that 5% under that assumption, then we're going to say not true. So let's calculate our standard error. It's going to be our 0.2 times 1 minus 0.2, which is 0.8, divided by 100, square root of that whole mess. Alright. Pull out the calculator. Let's go 0.2, enter 0.8 times 100 divided by square root that, and we're going to get 0.04. 0.04, alright, a nice even 4%. We like that. So now let's calculate our test statistic. Find out how many of these standard errors this sample proportion is below the assumed population proportion under the null hypothesis. So let's get our z-stat, to calculate our z-stat rather. 0.12 minus 0.2. Alright, that's the difference between our sample proportion and the assumed proportion under the null hypothesis. Divide by the standard error, 0.04, equals, check it out, 2 minus 0.04 divided by negative 2. Okay, so we've got a z-stat of negative 2. Alright, negative 2 falls here. Alright, this is negative 1.65, this is negative 2. This is outside past the threshold for our rejection region. So we know right off, or not right off, I guess we've been working for a while, we know right now that we're going to reject. I can put an arrow here, reject, exclamation point. Now, just for fun, let's calculate the p-value associated with a z-stat of negative 2. So our p-value gives us more exact information about exactly how likely it would be to get a test statistic of negative 2. We know it's less likely than 5% because it's past negative 1.65, but let's find out exactly. Alrighty, let's look in the z table. Negative 2.00 is 0.0228. Alright, 0.0228. Since this is a one-tailed test, we do not need to double this. We just say our p-value is 0.0228, which is about 2.3 2.3%. There's a 2.3% chance of getting something this unlikely if the assumption of 20% is true. So we're going to reject the null hypothesis, assume the alternative, that the true population proportion of students who want to go into public service is less than 20%. Let's double check and make sure that answer jives with the back of the book. Chapter 10, number 10. Okay, z-stat is -2, critical value is -1.65, reject, p-value 0.0228, reject. Alright, we're good. We're rocking and rolling. We're going to move on now to the next thing, which is hypothesis testing for mean differences.